Hello and welcome back to another video where we're continuing on with the Build Your Own Git course in Codecrafters. But part of that was we had to kind of do all the internals, which kind of led us to doing zlib decompression, which led to deflate decompression. And I think I have worked out what is going on. So the last few videos are a bit of a struggle street, but basically what this is like, you kind of don't need to do this part, which I'll get to in a bit when I kind of describe. But so I worked out which way that you need to do, and I've actually built a few Vim macros to kind of do some cool stuff, because I thought, hey, why not? I know how to do things. But yeah, the gist is that we are reading some bits. I've also got the debugger working with showing source code, which is somewhat useful. And so what I thought I would do is kind of step through this thing here. So if we get the data that we know, so the zlib stuff looks about right, and the way that this does it is about right. So if we kind of just paste all of this again and join them all up, except we don't want to join them all up. We want to first do a little macro, which actually makes use of two macros. Only does it once. But that's because I actually want to do it 15 times. The reason why I don't want to do that, actually I'll just make this a bit bigger. So if we go back up to here, so I've got a macro that in essence kind of reverses the bit stream and goes down a line. And if I did repeat, it'll just repeat the reverse. So what I instead need to do, and the reason why is because R is a macro to reverse it. But if I kind of eyeball down here and see that that is 14, I'm on line 0. Well, 0 relative to me, so if I go 15 and then do that macro, it will kind of reverse all the strings. And if I now go 15 GJ, it'll give me a bit stream. And what I'm going to do is mark this as a stream. And what that's kind of done is set up a little thing. So we can go final, and we can, at this point here, go macro B, and we'll get a byte. And things will kind of shift in this line here, which is what I kind of want. And so where does it say the block format? The next 2 bytes are the type, so we can get that. And I can go 2 at B, and I'll get 2 bytes. And the order that comes in is, oh, that's not right. Because I did it up here and it worked. So both of these kind of have that going on with it. I think for some reason I don't know, but if we do that and type, and this can just equal to that. I think with type in particular, you had to do it like this, whereas where it kind of just grabbed this. Nah, it does bits on that. Well, anyway, I'm gonna reverse the way I did it, and so here we can check whether it's not stored with compression. So we kind of just want to clear the byte, and that's easy to do, and then we'll read some stuff. Otherwise, we're doing some stuff, and the file that I'm looking at does not have dynamic Huffman codes, which is why I'm interested about that order. But now we kind of do a big loop, and we want to decode literal links and stuff. So we've got the type B1, and so kind of what we want to do is get 7 bits. So we can do 7 bits and see where this kind of lines up in this thing. And now these both kind of start with 0, 0, so it's not in this range. So because of the magic of Huffman tables, we can just add another bit to the end. So we're only reading as much as we need to. And so here we now have 2 options for 8, and this starts with 1, 0, and these both start with 1, 1, so it's not this range. So it is potentially this range, and by the looks of it, it looks like it is. So what you do is you get this number here, and you subtract I have less. Well, what I might do is I might just quit out of that one. We can, yeah, sure, do that thing. Is that pane 3? It is pane 3. It gets like hung up in like after bash log out. I feel like Tmux is doing some stuff. And what was this one? This was the one I kind of wanted to have kind of handy. And so if we get this, well, we have this, get that here, and we did that paste it like twice? No, that's right. And then we subtract off the 0, 0, 1, 1, 1, 2, 3, 4. And without a space there, we get 98, and so that's going to be, and then I suppose we'll add on this value. Yeah, that's kind of how that would work. So this would be 98, and it is a literal value, and then you would go back up to, golly, no, it was just the one level up, so you go up to this one. And then here you've got a few tables, but you ignore the tables and you look at the this one here where so basically I've got a value of this, and we can, like, the first value is 98, and it could be more if we chose to get more bits and whatnot. But in this case, we got this. And if we look at what that is, it's a B. And what's kind of important if we do this, yeah, so we just want to kind of look at this. It kind of shows this, but there was also cap file, there was the other one. I think this way up the top says it. So what if we get that? No, so like, if I don't do that, is that what it does? Basically, this isn't just going to decompress to that. And how I know is because I kind of ran through this a bit before. But yeah, this in essence gets us a value of b, which is a literal value that just gets poked into the output stream. And if we kind of go here and like maybe find this and mark that as our stream. This is kind of what I was going through before, and this is stepping through, and we get a B, and an L, and an O, and then a B, and then a space, and then a 2. And we can kind of continue on with this, so I thought I would kind of introduce it, then start doing a little thing on this. Now this one looks interesting because this is exactly on the border of this. So this is, I don't even, well no, this is 7 bytes, 7 bits. So it is just underneath this. Don't want to go too far. So, no, it's just over that. So it's one more than that. So we've kind of done this. But because of that, we do actually need to read another byte, which would, in essence, get us this extra 0 at the end, which wouldn't have mattered. I've done a thing which I've tried to zoom in on the page, but it didn't do anything, but it might have done something here. I don't know. Hasn't really done anything. But anyway, this value is the literal value 0, and did this table here say what that is? I think this is just the literal byte. Like null byte. So maybe I'll put in that, and I think from memory this is kind of what would happen. So this says blob blob blob, and like what's the data that's stored in it? Well, like this might tell us a bit condensed information. In fact, this might be a bit easier on the eyes. I kind of like the darker themed. Yeah, so we have blob, then a size, and then some content. So this is kind of alright. Because like we don't really know the size of the contents that we're building out, but at this point here we know the size of what is to come is, and I kind of want to go to my stream, and like I've still got quite a few bytes left to go. So we can see what happens when we kind of continue on. So we'll push in the wrong keys. Swapping keyboards about. I need to fix this other one. I think I just need to get the old rubbing alcohol out here to then rub on a contact that it has some green, and green is not the colour that contact should be. Right, so I guess we'll get back to this, and so here we've got a 1-0, it's not quite up to there, so this is just another thing. I feel like this is a kind boring compression where it's all kind of fitting into this literal value. So I could potentially, like this should be the A, I guess. Well, no, we need to get the next byte. Do that, and then go back into here and do that, and 1000, and so we'll get 97 again. And is that what I'm expecting? I wanted true of 97. Yeah, that is kind of what I'm expecting. That is the contents of my file. So now the more interesting byte will come. So we'll first get 7 bytes and 7 bits, sorry, and this is over the kind of this, so we need to get another bit, and this we have 111, so it's also in this range. I would have thought it wouldn't be. No, I'll need a new line, so this will most likely be a new line character, and we can that wasn't the key I wanted to do. That's probably enough. We can probably chuck this in 111010. That wasn't the keys. 111010. And so yeah, we got 10. So here is a 10, which is a new line. I wonder if this tells us this. Yeah, it does tell us that. So now I believe we get an interesting bit. So we get 0, completely 0. So we're in this one here, and so this will be a value of 256. 256. Now, this is where we still have like a bunch of bit stream to get through, but this is where 256 end block. So this is our like end of block, which is interesting because we do have a bunch more stuff. But yeah, value that break from loop. What is with the rest of the data? We just have like a bunch of leftover stuff. This is where we go back to here, and so this one's the zlib compressed data format. So zlib has one compression format, which is deflate, and this is kind of what I've been working on mainly, but the wrapper around it, zlib, has a idler checksum. So compressed data is stored, and then this contains a checksum of the uncompressed data computed according to idler 32. I wonder if there's a tool that I can use or like, does Python have a idler 32 idler 32 Python? I mean, I'll probably end up writing it, but yeah, it's just part of zlib. Import zlib. So zlib.idler 32, and if we look at the string a n of that, so we get a integer. Can we now I guess do a hex of that integer, and so that's what we get. So yeah, we just get a 32-bit thing, so this is missing a couple of zeros, and I guess we've lost our active bit stream. 1, 2, 3, what I'll do is 8 across and there, and 8 across and there, and 8 across there, 8 across there, 8 across. So that's kind of what we have left over. Find my waters. Has the result that it's given me just been because yeah, I guess what is the binary of, we'll do that and then we'll get the binary of that. So what's that kind of look like? That doesn't look like how this kind of starts, or really how this ends. Like we got this triple, this is 1, but it doesn't really line up. I'll just undo that just so when we pull a bit it does do this. Stop bit. So at this point there should be an headler 32 check sum. S1 is the sum of all bytes, and S2 is the sum of all S1 values. I assume you go in like byte order, so like S1 will be 1, and then S1 will be 1 plus byte 1, but then S2 will be 0 plus 1 plus 1 plus byte 1 plus 1 plus byte 1 plus byte 2, and so on and so on. So S2 will kind of get large, but we're doing modulo stuff. So like maybe I can kind of do this. Maybe with a little calculator. So S1, this is going to be 1, and S2 is 0. So the first one we're gonna S1 plus equal to is it ord? Yeah, the ordinal value of A. That's what we do, and S2 plus equal to S1. but like, what if it's done in the other order? We're like missing a one, in essence. So we have S1 and S2. So S2, I wonder whether it should have it like that. So we add it before we do that, just so we get all values. As it speaks. Right, so now we want to add on the next byte, which is the order of the new line, and then S2 can be whatever S1 was. So that's just all of them, and at the end we have these two values here. And then we're getting S2 times 6536, and off by 1. Do that, but plus S1 as well. And so maybe if we look at the hex of all of that, and that's roughly what we were seeing here. zlib, and the hex of that zlib things. So that was getting that, and that was getting that. So I think S2 didn't want that first byte, and then we get the same as that. So cool, that's good to know that we've done that. And then it's stored in that, and then most significant bytes. So it's kind of stored in network order, which means it's like kind of reverse, but like backwards reverse. So I mean, what do we have as our things? So we should have like 8 bits we can read. Oh, why did that get a 1 at the end? Is that correct? Because when I did I guess I did. Right, so if I get 8 bits, then we'll get another 8 bits, and then if I didn't do, I think I can just do that. No, or gosh, 8 bits there, and 8 bits there, and what do we have left in our stream? We just have 6 bits left. Don't know what we're meant to do with them. So this kind of seems like we should have pulled in more. This 256, the wrong RFC. So when it's 256, it is only 7 bits. So from what I understand from that is we don't have to read that. That's kind of what I'm thinking. Python network order. Oh, we had to do like random pact. Yeah. We can. Alright, so 256. I guess we don't need. Link backwards pairs. Alright, so we hit this, we break, and we were the last block. So we get into this, and then it just reckons that we need to store that. So let's see if we can massage this so we can. Nah, I don't know. Maybe we need to go in like reverse these. And maybe join back up, and does that change some things? Like kinda, but to like an odd position, so there'll be 3, so we kind of get a weird 100, but then this will be that, and I wonder if, so if we, no, we can't just like, has different things though. I don't know. We've just got some weird things, and we just have a single byte left then, but then single bit. But yeah, so this doesn't really kind of match up completely. So like this would then be reversed. So like have that reversed, and then this kind of matches the I have no, I want to redo all of that. So at this point here, I want to go there, and then at that point there. Oh no, I just don't know. It seems like kind of doing some voodoo things, and like then this wouldn't kind of match up. Nah, I don't know. I think I'm just doing things. I wonder if this. Yeah, this should be of the entire thing, which is really blob space 2 0 for blob 2 dash 0 dash a. And this looks like it might be a bit nicer. 4025D. So this would have like cool. And now if we get bytes, so we get E there, but if we reverse that, I wonder if that is that isn't what I thought, because we don't really have a go back to where I was. Gosh, that is quite annoying. I don't know. It might just make noises. Can I don't know. I'm kind of like on leave, but like my work, like I'm signed in to chat on my phone, which is now blinging because something's happening, but not for me. Right, so if we did this, and does it like include this 256? Yeah, I wonder if this is kind of well, no, we can't do that. Of the uncompressed data, so after we've decompressed it is when we do it, and this is the data, the blob 2 and a. That's our output, so it kind of gives us this. These are the values, but I wonder if I go back to my kind of solution. We can make a def adler 32, and this takes so I guess this takes bytes, then this is going to be bytes, and it's going to return us a. Can we do this? I think we can. Basically S1. No, you just say it returns an int and then we can do this, and in this, so we have S1 equal 1 and S2 equals 0, and then for B and BS, except I want to do something like that. That's Pythonic, isn't it? And then we want to do S1 plus equal to B. Do we need to do something like this? And S2 plus equal, maybe S1, mod, what is it, 65521, 65521, and then S2 plus equals S1, and then S2 equals S2 mod 65521. That is what we want, and then we just close the for loop, and then we probably just want to return at the end S1 and S2 as our return values, and then we return from the method. And so now we have, if we look at what Adler showed, we can probably do an Adler on the same blob to their AM, something like that, and they will return us two things, and so we can probably even do an unpacking type thing, and then we can show what the hex of S2 times 65536 plus S1 is, and we can just work out what order it is. And so this is the same, so yeah, I'm happy that my Adler thing kind of works. I'm just less happy that this doesn't kind of work. So of this thing we can a little nicer to see, and I think I want to do 8, put those back, so I've got another macro to kind of return things to the stack, though I think I might have no, that looks like it is right, so we can do a search. No, I want to do a search for that. So yeah, I did do some playing around, because it really should just be the end of this. Until like these two links are the same. And these do look remarkably similar, so I wonder kind of what's happened here. Because it's not the end of this one, which is the OG, but this is like the reversed bits. I wonder if after we do this, we kind of go to the boundary of this. So I'm going to get this. And we're going to just see if this kind of matches up anywhere with any things. What I want to do is kind of make this as long as that, so that would be that, but we kind of want to store it in the MSB, which means that if we 8 back, get here, and 8 back and get there, and 8 back and get here, and 8 back and get here, maybe 8 back and get there. Why is that taking 6, 7, 8 back and get there? That's odd. Right, so then we should get that, and this kind of looks right in a sense if we discard that, and then we get this. If we look at this, so if we look at the binary of 0b 0xe over e, but maybe we'll put like a ff, so there'll be a whole bunch of ones and then a 0 e, and we can kind of ignore that side of it and just look at this, and we can see it's 4 zeros, then 3 ones and a 0, and that's what that number there is, which looks pretty good. And so what is 6 4 and 1 1 0 1 0, and looks good. There's a leading 0, and then we have 2. That looks about right. And 5D, I would imagine, is right as well. So I guess, how have I got it? So I'm reasonably happy that this is kind of doing the right thing. I have an understanding of where the bits are happening and how to read certain tables. Unfortunately, I haven't got anything juicy that kind of says that, but if I had repeating content, I would probably hit that, so I could probably get in after. So yeah, what do we want to do? So pretty much as soon as we get there, we're wanting to read stuff but into maybe this, and I can kind of copy that, and it's like potentially a decent thing to put just in a comment here. Something like that. And so if that is the case, this stream here, if I get the 7, I kind of want to get the same thing as I was getting in the so I got 49, which is the 10101. It's a palindrome. Lovely stuff. And so if we look at what happened when we did this, we decided it was out of range, and that is because it's over the highest number of this, I guess. Yeah. So I guess if how are we getting here? We're doing some things. Right, so if code is greater than 0b 10111, and is that because this doesn't exist? So what does that kind of end up as? This is just 1, and this is e. So if code is greater than that, that means that we need to read in another bit. And the code was kind of shifting up by 1. So I think these wasn't quite doing what I wanted. When we get a bit, we want ret to equal ret up by 1, and then or on next, and maybe do something like that, and then we don't need to worry about this I thing. The I is the loop counter. So we could do an I plus plus. So I think that's kind of what it is, but I wonder if this now, now it wants it to be a dynamic compression tree. So I think with the bits, we want things to be round a different way if we how do I want to do this? Maybe this is like reversed. This is like we just have to do it a slightly different way if it is all like that. I love how I've pushed up something somewhere, and so what I can do is I kind of want to do this and do that, and then copy a whole bunch, and then we can go up to here, and this does this way, and then here we have another way which is reverse, is it just rev, and that will do it a slightly different way, kind of build it in reverse. And I think that's the way I had to do it. That's rev. And I suppose I should do a print bits rev. I usually print bits. Yeah, so it's fixed compression, and we scroll up, B type. So we got that and that. Yeah, I think that's kind of what I want. It will print it the right way for me, but it will build it up that way. Cool. So now if we've done that, I think I want to kind of get rid of some info things. I think I want to set this to be do that, and then we can kind of just run stuff, and it will take us to the place that we want. Where have I gone? We are here. Cool. So maybe this one here, I can just kind of comment that, and this one here is what we kind of want. So if we do that, we want to shift it off by 1, and then we also want to code or equal to bitstream next. So we just want to get a single bit of that. Right, so I guess what do we want to do from here? Perhaps I want to do, if this is just make sure I get the right things. See, that one doesn't look right. I was just eyeballing that, wasn't I? And so yeah, I want 1.7. But I'm thinking of and 1.7, that is that, but 1.8 will be kind of the next level up. So I think I want to do, if code is less than 1.8, we're going to do a thing like this. Otherwise, we're going to get another bit and then do some more tests, I guess. And so in this case here, we want to get the bottom. So this is going to be, so maybe I want this to be, I mean, what, we can only go up to that, so I guess we can have that. Just want to check one thing. That's all good. So this can equal to, so something that doesn't exist is perhaps 2.88. like we can almost give it a very large number of we'll start with that, and if it's that at the end, so if the result equals, this isn't really the result, this is, we're trying to get the like the linear literal, yeah, I guess this is the code. So if this is the code, then I guess we already have the code. Actually, no. So here we can just do code minus equal to, no, so we want to code plus equal to 256, plus equal to 256. That's going to be the final code. So it read code like that, and we do this, and so if it is bigger than that, we want to read a bit, and we're going to have some like indentation hell, but we've only got 3 kind of layers deep that we kind of need to go. So at this point here, we can test that if code is less than kind of this value, so yeah, perhaps we need to do an assert that like code is greater than equal to 0 to 18. That is just the case. It is, that's the smallest it can be, and like it shouldn't have got to that point because all of the digits up to there have been covered by this, and then we should get to this. And now it's an 8-digit number, but adding on a digit there shouldn't really matter. I feel, because we're already bigger than it. Yeah. So this is this is a bit higher up, so this is just 30. So that's our next lowest code. So now if code is less than equal to, gosh, this code here, which we'll have to, that's an F, and this is like an F minus something, but so we'll have an 8. We'll add on 3 to it, so that's 9AB, so this must be a B, and we can check that with then 0xB should be just missing the 1. So if this is the case, we fit in with that. Otherwise, if the code is less than equal to, we have another case here. Gosh, whatever the case of that. What did we copy there? I just want that, and bin of 0B of that. Got something weird in my coffee buffer. Oh, it hasn't. Bin of 0B, and we just have to do that one. different systems haven't fully set them all up. I don't want the binary of it, I want the hex of it. So this is C7. I kind of want to get rid of that. So if this is the case, then I essentially want perhaps to zero to 1, 4, 3 codes. Didn't even copy it. And this one here isn't even that, it's this one here. So we should have this is 256 to 279. And this, the codes are 1, 2, 3, 4, 5, 6, 7, and here we have 1, 2, then 1, 0, 1, 1, 1. That's just what it is. 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, yeah. So we have 8 codes there, and if it's this, we also have this, so this will be 280 and 287, and so this should be, these two will be 0, and these two will be 0, and have an extra 0, no extra 0, something like that. Otherwise, we need to do some things. So here we probably want to do an assert that it is below greater than this number. So hex of 0b, hex of 0b of that. Sorry people, sorry. So this will be 190, but we also kind of want to make sure that it is less than equal to, golly, just all of those numbers. Can we do that? No, we can't. 1, 2, 3, 4, 1, 2, 3, 4. And I should have known. I should have known. And so this will be the final case of 144, 144 to 255, and the codes will be what I had in the paste buffer, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, and this one here should be 1, 2, 3, 4, 5, 6, 7, 8, 9. Easy. So it's like a bit different to how things are done, but so this I kind of want to put a comment instead of this, and kind of just note RFC 1951, and this was the 3.2.6 compression with fixed Huffman codes. B type equals 1. And then probably don't have that because we kind of have it again here. Right, so maybe this another digit, and then go print bits of code maybe. And here we can do another digit. So this is kind of alright. So code first, we need to get off. Is it just that? So when it's in this case, we're starting from there. So we're subtracting off this case here. That's the max one. So this subtracting off just 3 0 3 0. That's what it is, but then we're adding back on 0, so we don't need to bother with that. So in this case here, we want to, so that's 0, and then we'll have 8 plus 4, so I believe that's like B0. Bin of 0x B0 is, or it's not B, must be C, C0, C0. Right, so after we do that subtract, we'll also add on 280, get that right. So just to fit in with the range that it is. And if that's not the case, then we'll get on this one. We've got some zeros, and we got so we have an 8, and then we make that a 9, but then we have a 190, which we check it there, and then this will be 144. So at this point here, we should get a valid code at the end. So we got an error. We needed to set this to be like something like minus C. Do that whole thing. Is that what we do? So and then then it will kind of show me all the things that I needed to show me. Right, so print bits needed to get done, so we can say that this is 8. And so that was 7, and we can do another one down here of 9. Keeping that window. C7, that's because it's 0, X, C7, B final. So I guess I'll just bring that in. I kind of don't want it to. I don't know why it popped up there. Because I'm searching for things. Yeah, so now if we run it, it will go here, but I kind of don't want it to be the first thing, so maybe what I can do is do like a void b type, b final, and track that down at the end of this function. And maybe do unimplemented. We have not implemented that yet. Cool. So we get this encoded. It's printing. It's not quite how I want. Print bits should do. Where do we do a print bits? We do a print bits there. We do a print bits there, and here and here. You know what? I reckon print bits can also do a f print f std error, a little new line fella. And then here we can kind of see what has been written and where. So here we can see that the final code was 62, and I kind of want to see what we decided the final code was. We decided it was 98. So not quite right. But we got this 92, so after reading that, so we're kind of just not doing the right subtraction, I guess. Perhaps we can do info. Maybe I will make a new thing, and we can call it yank this line, and then change that with that, and then that, and then that, and then that, and then find the next that, and then do that, and then if we do that, we should print out some things. Vim can do a bit of things if you ask it to. If we how do we best want to do this? We didn't do the new line, and I think just finding the that and doing that sort of thing will be a bit better. And then it can kind of say where it thinks it is. So it thinks we're in this range here, which is correct. Is that correct? That is correct. So we should be subtracting off this 92 from that lowest code, which was 30. So maybe I'll just do a quick compare that this was that. Yeah, so that looks right. And so what, 92 minus 0x30 is 44. but then here we have code as 62. We're printing in hex. I wonder if that kind of matters. Like maybe we can say this is 9 bits. So the this a dot temp we were reading in when we decompress this, so we got this, so we got 146 and we got it as 92 after reading another digit. That looks right. So after subtracting 0x30, oh yeah, so that is 62, and cool, that is right. That's the problem with hex and stuff, is like sometimes you kind of slip up as to where things are. Time for a refreshment. Right, so at this point we're kind of decompressing a block. Get out of whatever mode we were in. So in here, what are we calling it? It's fixed compression. Like, I feel like at this point we could join up with some other things, because this is similar. I don't know. I'll just kind of do this, but we should note that this is kind of now code is the first code used in RFC 1951 3.2.5. Compressed blocks at length and distance codes. Maybe I'll just do that, and we can do that. Because these are kind of the same. So I wonder if we could now kind of just do a deflate. I mean, where's that? This could probably get called something different. It gets called from decompress. I don't know, maybe I'll just call it deflate. Well, we're just deflating a block at the moment, but in this block we probably could do a deflate compressed block, and we could probably give it the string. And I'm just wondering, like, we do this and we get a code, and we'll just keep on getting codes until we hit 256. But we've already read the header, so we never need to do this sort of thing again. but in this we will need to do that. So like we kind of need to do this while the block isn't. Yeah, I don't know. The way they do it in the zlib source code, it does make a little bit of sense. Like using a state machine does make it a little bit easier, because then you can kind of recall into the same thing. They did have a few too many states, in my opinion, but it is what it is. I think I'm not going to make a new function here, but I want to do this if code is less than 256. We're going to have like output. So we don't really have output at the moment. So I guess we could have an array. Do we have like we have that sort of an array. So I guess we could implement a type of well, like I can do a define. Yeah, that's expected. Can help. So what is this? Zlib array append. And this is going to take an array. We kind of want to also pass in a value. And this is going to do a bunch of stuff. And it kind of relies on, we need a like define zlib array, and we can give it a type, and this is just going to return a structure with oh, I wonder if you can do stuff like that. It's basically going to have a size. I wonder if I'll do this, and I also wonder if I'll do this. Do that and fun there, and Josh fun there, and do that and fun that and fun that and do all that, just to make it a little bit easier to read. So we're going to have a structure size t size, and we're also going to have capacity, and we're also going to have a tip, and pointer to data, and that's going to do some stuff. So in our array, we first want to check if the array dot size plus 1 is greater than array dot capacity. If it is, we want to do some things. We want to do array dot data equals realloc. Is that what we kind of want to do? There is a realloc array. Does that do like so the problem with realloc is it doesn't really it clear the memory down, but I think that's kind of alright with what I'm doing. But realloc, what do we give it? We give it the pointer and the new size, I guess. So I guess new cat can be, and if array.capacity is equal to 0, then it can be something like 16. Otherwise, it can be array.capacity times 2. I don't know, that's a decent capacity size. And so now we can realloc, giving it a pointer to the current data, which could be nothing, and if it is, then it will just kind of work. And we kind of want this to be new cap, but times the size of we want this to be the size of array.data and the first element. I think that is what we want. And that's going to return us some things, and if, well, I've got assert kind of loaded, so I'm just going to assert that we got some data, otherwise we've just run out of memory, and there's bigger things to worry about than a program crashing. It's probably a good thing that the program crashes, but yeah. So at this point, we should probably set this to be our new cap, and I think that's the end of the if statement. So basically, we've made sure that we've got space in our array, and now we can just go array.data, and the element that we want to get is the array.size, and while we're here we can do a plus plus, but the plus plus doesn't apply the first time, so the first time size will be 0, and the 0th element is the one we want to do. The next time will be 1, and the 1th element, I love it, will be the one that we want to do. But if we've gone this far, we do that, and then we do this while 0, not while 1, otherwise we'll do it a few times too many. So now we kind of have two types. Now I kind of want to have like context that kind of chucks things round. So at the moment we're like kind of throwing around things. Maybe, nah, this is probably right. Well, I need to like somehow return a thing. And I guess I can do something like the lib array of, and we're just going to give it a array of unit t. I think this will kind of do it. It will like be like we're not allowed to do that. This is because we haven't kind of done things unimplemented just while I'm yabbering it along. So that kind of compiled straight away. So what I kind of want to do now is wonder why we could return. I think so I kind of want to make a specific array, so we can do a type def of, and we can do the lib array of uint at t, and this is going to be the lib data array. That's just what it is going to be, and we'll just return that, except because we're kind of doing that, I think it would be maybe a bit better to like kind of pass it in as a pointer. So what was it called? It was like a Z data array, and this is our ret. And this we can kind of pass in our ret, and so these things will all need our ret shortly, and no compression just does that, and then at the end we'll surely like say that it's succeeded, or like I guess at the end we'll just see whether it succeeded or not. That did a thing. That's all good. So this probably won't compile now. So this we gotta go. And we're back. So I think I was adding on, so we're adding on like a bunch of stuff like this, and what did I call it? Z-lib data array, and we were calling that ret, and so this just needs to be in a few places. That's alright, we'll use that soon. Too many arguments. Let's make that not, and so I just want unused for it all too few. So here we'll need a ret, and I guess we can have a pointer to it, and here we can make our ret. So this is going to be though this is just doing the decompress, so I wonder if I would just pass it in here, the lib data array, and we can call that ret, and here we can just pass in that. How do I want to do this? And here now we'll have the last so here we can pass in some stuff, and this is just in main, isn't it? Perfect. So here we would pass in a pointer to ret, and I think here we would do an if ret dot data, we'll do a free on ret dot data. Decompressed, maybe call that all that, just because we already have a ret. So now it's just we don't use things, so we can do that. Right, so it's just in here. I think I want to get rid of things, and I'm fairly confident that that's kind of working. No need for a debugger anymore. Right, so now what do we do in this fixed decompression? So if we were doing it here, we would want to do a zlib array append, and it took the array, and we can just pass in the code as is. So I think that is that. Code equal to 256. We want to do a break, so I guess here we want to do a do a big loop. So here we can do a, and is this like kind of saying it there? Yeah, I think this is kind of alright. So we're just going to do a giant loop, or it won't let me do that, but it will there. And here we can add in another one, and so at the start of every loop we should probably check that if code equals ERF, because is that something we return from here? Yeah, so we return an ERF. We should probably display that as an error somehow. Maybe we can just have a slightly incomplete thing. So I guess we we could call it a 64T. While the code was always we call it UN64 there. So we're going to have this and have something like this, and this is next, and this is going to be next, and we're going to have that. And so the other time we read another code will be here. So just to make sure that we have enough things. Right, so here we have these bits, otherwise we have not done this bit. We could get round to it as we do it, but I think for this we are all good, and so we could probably get rid of that. Right, so here we kind of need to call it just an int. That's all right, and same there, and same there. Right, so now what doesn't it like here? We need to pass in the pointer to it like that, yeah, and then that kind of goes and adds it all in. So I think at this point here I don't really want to print stuff there, and same there, and do I want to kind of point out things there just to condense the amount of stuff that we kind of read? I mean, that's kind of just added in. Right, so if it's doing that, and we're not hitting any unimplemented things, so I guess can maybe just comment out those as well. We're actually getting that final compression assertion. I didn't really notice that. So from this we get the final code. Let's have a little look-see at a.temp. A.temp was the one. So the bytes that we read. So we get 62, and then we get this. I kind of want to say what the codes are in here. So maybe I do want to kind of see where it's tracking, because I think it should be hitting a earlier thing, and from memory that was the case. Because we get the 62 again, which is the A, and then we get a 10. But that is oh no, yeah, I think I don't care about this assertion anymore. Can't be that low now. And here we get to a bunch of things. So I think I want to go back to these don't kind of get caught. And there's one there. So now we get to this point. So this is when we're deflating a block, and I think at this point here we have finished. Except we don't really check if we're the final block. So I think I want to maybe set this to 0 and then do a do, and then the final equals this. And then do a thing on get out of there, get out of there, and basically we loop into the final not equal 1. Yeah, that's probably good. So in this case, we will do it at least once. And I mean, we can kind of do this to see that it's doing it at least once. Redo that, save, and then run. So it's doing it at least once, but then it's hitting another unimplemented, which is when we are decompressing. So I think this is decompressed. So what I can do is see what it looks like. So I guess what we kind of want to do is just do like right. Can we do we want to do an F right to into a thing, or do we want to do just a write? I mean, the f write is maybe something. So we give it a pointer, and then we give it a size and the number of members. So our pointer will be decompressed.data, and our size is going to be 1, and the number of things is decompressed.size. It's a bit unusual there. The other way we can do it is if we just do write, which at the end of the day it kind of calls this under the hood. And like, do we? So we don't use. We're using fread and stuff. So I guess I'll do fwrite. And here, like the fread, our size is size. So I guess. Well, here, like, it doesn't really matter which way around it goes, but if we pump that out to std out, that's potentially what we want to do, and then we get that blob to a, and it does have an extra bit around it, but yeah, so maybe I don't want that there, and here we can kind of see what this looks like, and if we see what this looks like, no, we need to, there's a way to 7, 8, there's a way to kind of just tell me what it looks like. I thought there was a way. These are all on that one file. I mean, I've got enough that I can maybe make some progress on the actual thing. I would get a new version of the app. So I guess maybe we can kind of change this into a header-only library. Like, does your program? Yeah, so I think your program does a compile from memory, but it only looks at main.c. So what I kind of want to do is in source main.c, I kind of want to include a we can define the lib implementation and then do an include of the lib.h. So I think that's kind of what I want to do. And then here we do a source clib.h, and we'll do if in def zlib.h, define zlib.h, and zlib.h, and I wonder if like zlib itself kind of used it, so like it may kind of clash with that. And then after this we do like a if def zlib implementation, then we do the implementation side of things there. So if we look at what zlib.c does, what we can do is kind of yoink all of this into here, and these can be implementation type stuff. Here we can maybe like, I don't know, there could be like overloading of reachable, define that, and then end if, and then do the same for unimplemented, and if, and then do the same for that wasn't the key, info, and then end if end if c array len, and because like these things aren't like specifically related to the zlib stuff, but we can kind of have them in there. The print bits, the zlib array type stuff. So zlib array, we do kind of want to kind of yank up into here, and then I guess we can type def all of this up into here. So, if we do your program, it is currently compiling with both this, but that one still compiles. So what I want to do is maybe get this and say this is the thing that I want to accept. I think that is probably all the things that I actually really care about. The rest is, it just happens in the inside. And the like this stuff could kind of get spit out into deflate, gets done separately from the zlib, just to make it a bit clearer. So I guess if that is the case, we have this thing here, and in main we have a cat file, and we have some error checking that we could do, but what I could do is we get this, we read in a buffer, but we really want to like we could either read in the entire buffer as is, or we can kind of pass into like a zlib stream. Until we have more bytes to read, in essence, because at the moment we're kind of just spitting it straight back out to standard out. And the way zlib itself does it is it basically returns from this big inflate function, and if the state isn't in the right place, it will like you basically need to call it again after getting some memory, but I mean what I could do is just read in the file in its entirety, which I think is kind of what I want to do, and that sort of thing is kind of done like here, so we could potentially kind of yank this and I don't know, like paste that there, and this can be like do we have bool? Yeah, we do have bool. File read contents, and we're just going to give it a const char and file name. So here we're going to, this can be file name, and what are we going on with this expect thing? There was like, maybe I do want to kind of bring that expect. So we're kind of doing this sort of thing, except this is going to be a bool, and this is going to be returned false if that's not the case. But it does mean that at the bottom of this we have a bunch of stuff that we have to do in our return. So if we don't even have it, but down here we will have a bunch of things that we need to do, one of which is the file and potentially the data. Well, this is like an interesting case. So if rect, if we want to close the file no matter what, if we failed for some reason, we want to do that. Otherwise, we just want to return the thing. And the data we return, we don't have this decompressed data. That's something that will just happen. Well, I guess this can be the uint8 t. I kind of need to know the file length as well. So I think I need this to be uint8t data, and this is going to be long size. And so here we can say the size is that, and here we can say dash data is that, but we need 2 dashes there. And here we would need a dereference one of them. Size, we would need a dereference. Size, we would need a dereference. So it might be better to like set it a bit differently, but and then we would return what we want. And so this would probably default to true, which was not at the case. Cool, so that kind of just slurps in a file and tells us the file size and whatnot. So down in this object thing, so instead of doing this, we can kind of just have a uint8 star file data, and we can set it to null, and we can have a long file size equal to 0, I guess, and we can file read contents, that's what it was, and we can give it the object path. Is that what we want? So I guess we don't need to do the object fd, and this doesn't need to be a thing. There is no error at that point. Right, so if this didn't succeed, then we need to do some things. So this couldn't read object file at for whatever reason, object path. So now all of this stuff isn't kind of relevant. And what do we do after we read the contents? We now want to do a zlib decompress, and what did this give? Does it not? So in source zlib.h we had this, and so that is what we want. So we want to pass in the file data and the size. So this should all be fine, and then we kind of want to get the pointer to our rect, and we probably need to make a rect, and this can just be that sort of thing. And so I think that does that, and this doesn't really return true or false or anything. Probably should return if it failed. So like if this failed for some reason, we can just say that there was some error, couldn't decompress object file at that. And I mean, that kind of means that we need to did this kind of still work? So this didn't work anymore, but if we did the set to that, so this now doesn't kind of do the trick, but if we define zlib implementation and include zlib.h, but it was in source, so that still gets the right thing. Just want to make sure that don't break anything really. So after we read the contents, do we close the file? We do close the file no matter what, but we don't free the data unless we need to. So in here, we should probably do that freeing of the data. Free file data, and we should probably do that here. And what do we have open at this point? So this is where things get a little thing. So maybe this expect and whatnot can kind of come up here, but we're doing an int, and we'll start off with that. So this can be a 0. So we'll also need a defer type set up. Is that? Yeah, that's as far as we go. Right, so we will free file data, but only if file data not equal to null. Basically, if it is a thing, and that means that this needs to be set all the way up the top, really, and then file data doesn't get set there. It gets used, but that's that. And then this can be return defer. False. We'll do return defer. The expect isn't really going to be of use. But there are a few things that kind of need to be kept in track of things. So object path, we do a malloc. So there we can do an object path as well, and that does a bunch of return defers, file read contents. File read contents should surely take in a pointer to the file data and size, surely. And this one here as well probably also needs to be up here. And now down here, so we had a few things that we should probably clear up. So file data, easy, and if objects path not equal to null, we also should free up that. And if ret.data, we probably also want to free up ret.data. And that's all that stuff. So the ret is actually decompressed, I guess. And the sealer decompress is decompressed. So ret equals, so this should be decompressed, just to avoid that sort of thing. So maybe I can do set make prg equals your program. Does that kind of work? And then it should compile, except not compile. Right, so size is not good here. We had a pointer to it though. Right, invalid use of expression here. So that is because in source zlib.h we should also include bool, and I think everything that is returning a thing, have so much stuff that don't really care about. These should all return a thing. That's a bool, a booldie. So this is false, false, false. And I think I want to make this return true and this to be unreachable. So the only thing that should break out of it is if the code is 256. Cool. And here, make this also bool. Just make it return false for now. And here, this is also bool, and here we should probably just return true if it's gotten to the end thus far. But I guess we should also do if not this return false. If not this return false. Not this return false. Something like that, and this should probably just be a return false. Shouldn't be getting that. This should also be return false. false like that. And then when we do this, we can just return that. Well, actually, we want to correct. We can do something like if not deflate that, return false. So the problem with doing it, like reading bits in as you need it, which would be kind of useful for other things like network things, like you don't know how much you are going to read. With files, it's kind of easy because you can ask the file system, hey, how big's this file? But here we kind of drop the bit stream each time we call this decompress. So it'll be kind of useful to keep the bit stream round if you were doing the repeated things, and then the bit stream can kind of pull from that. In fact, I could almost make, why don't I? I'll do that at the end. So if this is the case, we can just return false. And this is, it says void up there, but it's actually that. Right, so we don't, if we get this file, we have returned true, but we should fix me check add blur 32 code, because there is more stuff to come. Right, so that all kind of works there. If we open up the zlib.c and do that one, so this still works, that command there. What I kind of want to do is change this. Where are we? I want to go into there. Can we go there by doing that, maybe? And so instead of here, I kind of want to just take a bit stream and call it a stream. We call it stream there. Streams like, we call it bits. Maybe we'll call it bits. Right, so we want to make sure that we have enough bits. So I guess like it's kind of interesting. If we don't have enough space, we should just return false, I guess. Like we can't do anything more, and I guess that's if it would get like way down the traffic. Nah, I think this sort of change is a little trickier. It would need some stuff changing in here where we get all the bits. So we have gotten a bunch of bits. Maybe this function is not the one to do, but say we get this bit, so we have consumed 7 bits. Was an EOF, but then we try and get one more bit, and it was EOF. We should kind of unroll what the stream was looking at based on that. But I think for now, yeah, and that kind of like looks good for most of it. It just takes a stream and a return kind of vector. Right, so that does that. So in this one, after we decompress it, we should probably make sure that this is showing the thing. So we have like a blob object. So the if str in cmp So if our decompressed, we should probably if decompressed dot size is less than 5, so we got 4 plus the 1 for the space, so that gets that. This is like unusual, so this is decompressed data too small, and we can just kind of say that don't want to see it, find that, do that, and also there, and got one there, easy. Don't have too many errors, could have more. Right, so if we have that, we now need to make sure that it checks with blob, and this was 5, not equal to 0. I think this is kind of what we want to do. So if it is not equal to 0, we have an issue. So decompressed data is not a valid blob object. It's just not. Otherwise, the size of it, luckily it ends with a 0 byte here. We can kind of get a pointer to the size printer. So this is a char star, and it's going to equal to decompressed plus 5. And this is going to be decompressed.data, and this is going to be decompressed.data. So at this point here, we should be pointing to size. And so I think I want to make sure that if not is digit, size pointer, we could even do decompressed.data 5. Yeah, do something like that. And I mean, that's almost the same error as that. I think I don't want that. Right, so if, and like we probably need a C type, which we don't have. C types, is it C type or C types? I think it's a C type. It is. Right, so here we probably need to say it's a char star, and here it can be a char star. That's just becoming a char at the end. Right, so here we get it's a valid object. So I think I want to kind of get this showing what it is meant to be doing, cat file. So I want it to be kind of running this minus p, and that random hash there. Is that the random hash that I want it to do? So if we get to Codecrafters and cat file minus p, yeah, that gets the single A. So at this point here, we can get the size. So we want to have like SDR2 L, I guess, is what we want to convert a string into a size. And so we have a kind of notion of an end pointer. So we would give it the this is going to be the char star decompressed dot data plus 5. So we're going to point it to there, and we're going to give it a pointer to end, and we're going to say that this is like decimal, so it has to be decimal. So this is going to return us a number, so this is going to be blob size, and it can equal to long, I guess. So what do we do with the blob size? I guess we need to it's kind of interesting. I don't really make use of that because I've just decompressed the entire thing and decided that memory is cheap and I just have all the data. But I guess what I should do is maybe do and assert that blob size equals decompressed dot this is an error if what were the error cases? Error cases were if end pointer, so pretty much end pointer is not null, then that would be a bad thing. So if n not equal to null, couldn't get the size, invalid blob size, so that's going to be that. Otherwise, this should really be the decompressed size minus 5. Wow, it's really the end. Decompressed dot data plus the entire size minus where we are currently at should be right. So pretty much the end pointer should point at this null byte here, and so if we get the start of it, we add on the entire size, we should be pointing at here. If we subtract off where we are currently, we should just get the number of bytes in between, and that is my hope. So if we did a return on this, it doesn't like this. What are the types? It doesn't like this part. No, I've got one. So this we can just call it a char star. Unknown command P. That's because we actually want to do. Can we do this even? We want to do cat file, do that. And now if we run that, invalid blob size. Alright, so invalid blob size, it got down to this final one. So what do we have here? We can say printf blob size equals, and we can give it that, blob size, and we can say blob data, and this can just be string actually, decompressed data, and probably need to do a char star blob size data, and this is going to be +5 there. In is not null, so we'll have a look at what it is. So blob size is 2. Alright, so what is the current character under this? It is 0, and that's because we want to check whether that is null. So we should have a valid blob size, but that is because I want to do something like that. Right, so now we have a different error. So what we can do here is we can print out blob size is we probably have to give it a L there, and we can call it blob size, and decompressed size is decompressed dot size, and so this is going to be like data end minus blob end, and so this I hope is going to be so we need to make it a char star, and then we decompress dot data plus decompressed dot size, and then subtract end off that whole thing. Right, so we haven't given the thing, and this we can also give the thing. Right, so blob size is 2 and 9 and 3. So we're like, we haven't swallowed the one, I guess. So this whole thing, this data n minus blob n, this whole thing is like 1 more than what it is, and so what I think we just need to subtract off the 1 there, and that's kind of that. And I think I can probably just do an F right, and F right, and so we pass in a buffer size number of members. So the buffer is going to be decompressed data. Well, it's actually going to be end plus 1, and blob head end. So this can be called blob head end, and this can be blob head end, and this can be blob head end. and then this can be blob heading. It just makes it not look like I'm just adding one to the end and being like YOLO. And so the size of this is going to be 1, but the number of things of that size is going to be our blob size. And we're going to write this all to std out. I believe that's kind of where we kind of do things. And then we don't free file data there because we're doing it back down there. And now it prints out A, which I think is in essence just everything that we wanted to do. So if we did that, that does that. If we did it under our git command, it's a little slower. It took a little time to think. So that took what, quarter of a second, maybe the same time. Maybe I just ran the same file. So if we do that, yeah, so that's like no time at all, very quick, whereas mine is usually around quarter of a second. It is what it is. I can speed it up. There's a lot of like memory redundancy, but it is what it is. Just check this. But yeah, I think that is fairly good. And so, like, kind of, what do we need to do for the test? I wonder if this is just everything that we kind of need to do. Yeah, I wonder if we can do maybe do something like that. Won't do that. We'll do that. What info is this? Yeah, sure, we'll do that. And we'll also add in source zlib.h. We fast GTI. Sure, I'll add that in. Commit. So get zlib.h. Add zlib.h for decompressing object blobs. So how do we do this? Codecrafters test, is that what I want to do? And it will run a little test little thing and tell me whether I got things right or wrong. Potentially wrong. But yeah, see how it is. We've got a build. Gosh, it has to compile things. Right, so we haven't implemented zlib compress. Is that right? So if we look at source at zlib.h and 317, I reckon. So we haven't done it if level has a different thing. So we can kind of see what the if level does. We don't really need to care about this, but what we could do is maybe print a warning. So we have an info. We could maybe define a warn and maybe even just replace info with warn everywhere. And we can just do a warning, warn if level not 0, not used, decompression, but useful for recompression, ignoring we can see what the value is, I guess, and then pass in that, and we'll do that, and yeah, cool, that's done a thing. And so it didn't really say what it did to get to that point of testing. We also haven't done this Adler 32, but I mean, I did it in Python. It wasn't that hardy. Just sum through and add them all up. So we get that, and then we get another unimplemented line there. So 181. So here we have the point where we're in this one where we're reading something that is high. Basically, we need to kind of look up these tables, but I think that is probably good for now. I feel like a bit frazzled in the head, been working on this a bit, staring at bits and bytes and whatnot, but I'm pretty happy with the progress. Got my A out, and that's all I really cared about. The A being the content of the file that I hashed up. But yeah, the spec is just something else, but yeah, it is what it is. Thanks very much for watching, and I hope you enjoy this and stick around for more stuff like it. See ya.